Well, hello, everybody. I'm Terrill. I'm just going to stick with my first name because my last name and where I come from isn't important. I don't have enough time there, Chris. Did I use it? All right, that's already 10 seconds. Anyway, what I really like to do is try to introduce maybe a new concept, a new thought for something you to think about that maybe you haven't thought about before. So what I'm interested in is trying to understand the efficient frontier. If you're a finance person, this is like second nature. But basically, it's, if you had a bunch of assets, you had a portfolio of assets, and you want to get the highest return you can based on the risk, et cetera. What's the optimal portfolio to have to get that highest return given the amount of risk you have? Long story short, I'm applying that towards education. So I'm interested in doing in this process is what's the optimal mix of training for people who are interested in this zone here, who want to go from an undergraduate degree or a professional degree into the master's realm for whatever reason they've chosen they want to get a formal master's degree. So the question is, what can I do? What is the optimal mix to prepare them for that master's degree so that when they do enter the master's programs, they're not going to be blindsided by some aspect of electrical engineering they weren't trained in, or some aspect of computer science, or some aspect of physics, or some aspects of mathematics. Because as you all know, undergrad, we're kind of, we have a little narrower field of vision for a number of valid reasons. But then when you get into the quantum space, you're going to be sitting next to people who are from electrical engineering, computer science, and so on. So what the thinking is try to get those students acclimated in these other fields, because it is a multidisciplinary field, is quantum technology, and so that they can, when they get in a quantum into a master's degree program, they don't have that 6 to 9 months of getting acclimated and stuff. Some of these programs are only a little bit over a year old, a year in length, so you don't have a lot of time to get acclimated. You got to, if you can hit the ground running, you're going to be in much better shape. So what I'm talking about presently, FYI, there are 37 master degree programs globally around the world. I'm fairly confident on this number. I've got a lot of sensors out there telling me when a new program pops up, but quantum technology, this would include a master's degree in optics, for example. I'm very lax about what is the definition of quantum technology. To give you an idea, there's 37, and 2 months ago, I added 2 new programs. So looking at this point, about maybe 4 or 5 per year. And I only add it to the list once a student is eligible or able to apply to that degree, because there's a lot of works in progress going on in many, many universities. But my point of, okay, it's real is when they take in student applications. So anyway, I'd like to tell you about this experiment or project called the Master Degree Incubator. So the idea, obviously, is to incubate people and prepare them for this master's degree. So you can think of it as the yellow thing there, the block there. I'll show you a more detailed example of that, as the program I've been working with over the past 12 months or so. And the idea is take these undergrads directly, or undergrads who went to a professional degree. But the main point here, the end game, is they generally want to get into a master's degree program. And so again, commonly, I hate using the term, but commonly an undergraduate is fairly one-dimensional. But in the quantum space, you need to be multidimensional. And so basically what we're trying to do is fill those potholes, intellectual potholes, I like to call them. So back in, I guess in May, we started. So this is a series of courses that are free and available to the public, but are operated and delivered exactly as a master's degree program, with the same amount of rigor and expectations that we have of master's degree students. So we start out with a core program, 14 weeks. So this is held on Saturdays, and where we introduce people to the mathematics, the physics, and Python. Because when I interviewed many program directors in the United States anyway, that's what they told me. They need their incoming students to get the math down, have the physics, and the Python. So we started with that. So that's like a 14-week course. And then as we learned from that, then we started to think, okay, well, obviously, 5 hours on Python isn't really going to move the needle very far if you've never been exposed to such things before. So started to take it really 4 weeks at a time and take the different disciplines. So back in like 2 months ago, whatever it is, we ran 4 weeks of computer science, which is my comfort zone. So, but then we just finished a week or so ago, we just finished electrical engineering. So we're, in 4 weeks, 8 hours total, you really can't accomplish much. But, a smart person who's got those credentials, an undergraduate degree in STEM and or some professional work experience, they pick stuff up pretty quickly. You just got to deliver it to them in a meaningful and effective way. So we've got also a graduate seminar now, just like graduate school. So that'll be, we got that coming up over the next 2 weeks on Saturdays. And then if I could pull it off, a Foundations of Optical Engineering coming up in either February or January, because it's January, a little sooner than I'd like. But anyway, but then, so it's even in an HPC high performance computing course. And so try to get these people well-rounded so that when they get into those master's programs, they're hitting it full steam. So to give you an idea of some of the topics, on the computer science side, one thing I'm passionate about is getting people to understand Monte Carlo experiments and that sort of thing, which most quantum people don't, in my experience, don't really realize what Monte Carlo methods are. And that's what a quantum computer is doing. Electrical engineering, which you just finished, analog signals, digital signals, going from one analog to the other, et cetera, et cetera. That's a Fourier transform. We get into fast Fourier transforms and stuff like that. These are things that should be, in my experience in talking to people, these are things that should be second nature to somebody going to the quantum space. You can learn Qiskit overnight if you have these basic fundamentals. So to give you an idea of some of the assignments, these are graduate level assignments that we're throwing out there. I just randomly picked 3 of them. I guess my resolution isn't that good, but one of the ones that I like the most is using the Monte Carlo method, write a program to discover the prime numbers that are less than 100. That, if you're going to be writing quantum algorithms, you should be able to just figure that out in a few minutes in your head as to what that means, and then you execute it, in a couple hours or so, even less. But anyway, basically, we're really trying to bulk up their cognitive skills in a variety of settings, because that's what you need in quantum. Give people, those perspectives across these different disciplines that we're usually siloed into through undergrad and our jobs and stuff. But really, what's really important is getting those undergraduates transition to those graduate school expectations. Because anybody who's gone through the educational system, if you think about it, right, you're an expert high school student when you graduate, but then you go to undergrad and it's a different ball game. And then you finish undergrad and you go to graduate school and it's a whole different ball game. The things that make you successful as an undergrad is not going to make you successful as a PhD student. So, we got some of it, do it, DIY. We just say, go figure this out, that kind of thing. At the end, I give a letter of recommendation. This is not a university-sponsored event series here, but I give a letter of recommendation that hopefully the program directors down the road will have some value and consider that when these applications come in. And one thing that you always get blindsided by something, and this is a good thing. One of the programs here in the United States has 3 students that went through this, or are going through it too. And it turns out when they started classes in September that they already knew each other through this program, which is like really cool. So there's a social aspect to it too, which that was the surprise. So again, I just want to take it back to, all this other stuff might be noise, but just think about we as a workforce industry, you know, what's that efficient frontier? That's what we really got to figure out here. We don't want to be inefficient, teach stuff that they don't need to know. But you know, that's essentially what we're trying to do here. And in my case, I'm focusing in on this master degree entry level because that's a place that really doesn't get a lot of attention at the moment. So hopefully this will spark some ideas and some strategies, et cetera. But anyway, that's it for me. You just lost the screen there, but I think I was right on time. So thank you for your attention.